Hi, welcome to my channel Cloud with Girish. In this video, I'm going to show you how to build a serverless generative AI retrieval augmented generation solution to implement a single document knowledge base using Amazon Bedrock, Lambda, and API. With this solution, I will create a social media analytics assistant that can provide contextual responses based on the past 6 months of social media data in a CSV file stored in a S3 bucket. This data include metrics about Twitter, Instagram, Facebook, and LinkedIn for the fictitious bank MyBankGB. Chat with your document is the latest generative AI feature added by Amazon to its already feature-rich areas of Gen AI, knowledge base, and RAG. RAG, which stands for Retrieval Augmented Generation, is becoming increasingly popular in the world of generative AI. It allows organizations to overcome the limitations of large language models and utilize contextual data for their generative AI solutions. I will use the recently released Anthropic Sonnet Foundation model and invoke it via Amazon Bedrock using Lambda and API. There are many other use cases where the generative AI chat with your document function can help increase productivity. For example, it can assist technical support in extracting information from user manuals for quick resolution of customer questions, HR departments in answering questions based on policy documents, developers in accessing technical documentation for specific functions, or call center teams in addressing customer inquiries quickly by referencing product documentation. Let's look at our use cases. MyBankGB, a fictitious bank, has a social media presence on various platforms like Twitter, Instagram, Facebook, and LinkedIn. The marketing and social media team would like to analyze 6 months of data from these platforms to identify trends in top impressions, engagement rates, likes, followers, and other data points. A report in CSV format containing 6 months of data is stored in a S3 bucket. MyBankGB is interested in implementing a generative AI solution using the chat with your document function of Amazon Bedrock knowledge base. This solution will enable the team to quickly query general information and train from this data without building additional reports or running SQL queries, thus saving time and improving overall productivity. This solution will be developed using an API, allowing either team to invoke it directly using an API validation tool or integrate it with any existing application. Let's look at the architecture. We have the user or the consuming app invoking the API, which is hosted via AWS API Gateway. A prompt is being passed. Prompt is the question that team is asking, and it's being passed to a Lambda function, which is written in a Python Boto3 library, and Lambda is invoking the Amazon Bedrock API. API Bedrock is using a knowledge base, consuming the social media analytics report for the past 6 months of data posted in the S3 bucket, and it's the RAG approach that Bedrock is using and providing the contextual response back to the user. For the workshop, need familiarity with AWS console, some knowledge of Python Boto3, knowledge of AWS Lambda, and the basic familiarity with generative AI foundation model and RAG concepts. Let's get started. We're going to review the Bedrock service. We're going to review the foundation model. We'll review the RAG and the feature of Amazon Bedrock chat with your document. We need to request the model access and look at the console as well as the SAM template and the Lambda function. I'm using the serverless application model, so I will build this function locally and invoke it before deploying to the AWS cloud, and then we will review few of the responses. Since it's an API-based solution, we're going to validate it using Postman. You can use any API tool of your choice. I will use Postman to pass few prompts and review the response. I will be creating the Lambda function via infrastructure as code approach using AWS serverless application model and CloudFormation. However, you can create the Lambda function using the AWS console as well. SAM is a powerful tool for developers to develop and test Lambda function and API endpoint locally, validating and then deploying to the cloud. If you want to learn about creating and testing Lambda function using AWS SAM, please watch my video on Lambda workshop. Link is in the description. Let's look at quickly the Bedrock service. Amazon Bedrock is a fully managed service that offers choice of many foundation models. And this, since this is another serverless offering from Amazon, it allows integrating with popular foundation models and also allow to privately customize foundation models with your own data using the AWS tools without having to manage any infrastructure. Many foundation models supported like AI21 Lab, Amazon, Anthropic, Cohere, Meta, Mistral AI, Stability AI, and so on. Anthropic is one of my favorite model. It has like Haiku and Sonnet and few others. So I will be using Anthropic Sonnet for this workshop. Before any model can be used, you need to request the access to the model. For Amazon model, typically it takes few minutes to get the access. For Anthropic Sonnet, depending on your case and account, may take few minutes to few hours to get the access. Let's review the RAG. In the realm of generative AI, Retrieval Augmented Generation addresses the limitations of large foundation models, which typically provide generic response based on user prompts. One significant drawback of these models is their tendency to generate outdated or inaccurate information, a phenomenon known as hallucination. Additionally, these models usually lack citation sources, leading to responses without verification, and many prompts yield answer without acknowledging when a good answer cannot be found. RAG allows enterprises to enhance information retrieval by implementing a knowledge base that houses enterprise documents or integrate with vector databases. This approach provides more contextual and accurate content retrieval, improving the reliability and relevance of the generated response. This workshop is actually a compelling example of like this RAG because we are using our own hosted social media report with 6 months of data, which will be utilized by the LLM to provide a more contextual information, as we will see in the responses. So this is how like if you are using the console, this is how like the screen will look like, where it's a new feature, so we can use it via console, AWS console, or we can use SDK to invoke it via Bedrock, Lambda, and API. So you select a model, you provide the document, you can either upload the document or you can point to the S3 bucket, which is hosting the document. And once you do that, then you are ready to like chat with the document. You can ask the question and you will get some contextual responses back. In my case, I'm not using the console, so I want to show the approach of Bedrock API via Lambda, and actually I want to use the serverless application model. So let's look at the SAM template, which is basically going to define the resources, and then we'll look at the Lambda function also. So in this SAM template, I have two resources defined. One is the REST API and second is the Lambda function named as social media analytic assistant function. I'm using the Python at the runtime. My timeout is 120 seconds. And then I have some environment variable just to get the flexibility of changing these value. So I have the model ID in my environment variable, and then I also have some infer configuration parameters like max token count, the temperature, and top P, and so on. Let's look at the Lambda function. We have a Lambda function. I'm importing a couple of libraries which are needed inside the function. I have some logging statement. I'm creating a Bedrock client, and then I have a function retrieve and generate where I'm configuring the information and for the Bedrock client, retrieve and generate function. And then in the Lambda handler, we are invoking the function after doing couple of checks and providing the response back to the user. I'm also extracting the citation information, as you will see in the response. I'm building the function using the SAM. That's why these commands are here. SAM build is the command to build the function locally, and once build is successful, then I can invoke it locally before deploying to the AWS cloud. So the command for that is SAM local invoke, and then I'm passing the function name and the JSON payload. Once everything looks good, I can deploy it in the cloud. I'm going to validate my endpoint using the Postman, which is one of the API validation tool. You can use a tool of your choice. I'm using Postman to pass prompt to the Bedrock via API Lambda. Let's look at a couple of responses. So I have my first prompt here that I'm passing to the API, that please provide a summary of new followers. And as you can see, I'm getting a response back, and I'm getting a summary by each social media platform: Twitter, Instagram, LinkedIn, and Facebook. And not only I'm getting the response, but I'm also getting the source, the citation from where this data is being fetched. And that is the nice feature that a knowledge base and RAG approach provides, that you can have the source citation also provided in the response. Let's look at another prompt here. So here I'm providing a prompt to analyze the trends in engagement rates for each social media platform over the past 6 months. And as you can see that from the Gen AI solution, I'm getting a pretty detailed response here, and getting the engagement rates for each platform by using this 6-month data report that is posted in our S3 bucket. And again, I'm getting the citation and source for that information. Let's look at another prompt here. So here I'm asking for comparing the monthly engagement metrics like total engagement, the like, the comment, the shares across all platforms. And again, I'm getting the information back, and it's telling me, a pattern based on the information. And again, I'm getting the citation. This is just an example. Your data could be 3 months, 6 months, 12 months, whatever it is, right? As long as it is posted in the S3 bucket, and then you run the API, and you should get the information based on the data that you are providing. So let's look at one last prompt here. Provide a summary of net increase in followers by platform. Again, by looking at this 6 months of data, this Gen AI solution is giving me a summary of like, hey, this many for Twitter or Instagram or LinkedIn or Facebook, right? How many followers have increased. Again, this is a sample data. Your real world data will look very different, but you get the point that how I'm using the Gen AI solution along with my own report as a knowledge base, and then getting a more contextual responses back, and basically like it's a clear case of increasing the productivity, right? And the speed, because I'm not doing any complex SQL query. I'm not joining multiple data sources. I have the report that is posted, and I'm simply chatting with that document, asking the question, and I'm getting the response back. CloudWatch, that's an integrated feature. So based on that, I'm using the Lambda, and I have the logging statement in my Lambda. I can actually go to the CloudWatch if need arises and look at the logging there. So with this workshop, a serverless generative AI solution has been successfully implemented to create a single document knowledge base using Amazon Bedrock, Lambda, and API. This solution includes a social media analytic assistant that can provide contextual responses based on the past 6 months of social media data stored in a CSV file in a S3 bucket. As generative AI solutions continue to improve, they will transform how we work and bring tangible benefit to many industries. This workshop demonstrates the power of AI in solving real-world problems and creating new opportunities for innovation. I hope you enjoyed this tutorial. I'm working on some other exciting content on various AWS topics, which will be posted soon. Please don't forget to like and subscribe. Thanks for watching.